So today let us see what digital instruments are. The digital instrument basic circuits involve the use of logic gates and flip-flops. A logic gate is a circuit that produces a desirable high or low output voltage when its several input terminals are all at the prescribed high or low input voltage levels. So digital instruments are rapidly replacing the analog instruments because of their easy readability, better resolution and higher accuracy. Digital instruments display the output in the numerical form, that is in digital form. So digital instruments are used to measure the voltage, current, the power, frequency, etc. To enable digital instruments to recognize information inputs, which are analog in nature, must be converted to digital form. Hence, any digital instrument consists of an analog to digital converter as its input stage, that is, its first stage. The basic building block of a digital instrument has an analog to digital converter, the signal processing unit, and finally the display. So any digital instrument may consist of the following components like the resistors, the capacitors, the transistors, the linear ICs, the digital ICs, the display devices, analog to digital converters, digital to analog converters, etc. If analog readout is required, a stage involving to digital to analog conversion can be included before the display unit. So here the instrument which represents the measured value in the form of the digital number is known as the digital instrument. It works on the principle of quantization. The quantization is a process of converting the continuous input signal into a countable output signal. So, the instruments that are used to express the measuring quantity in numeric format is known as the digital instrument. So quantization is the basis of working of a digital instrument. It is an act of transforming an analog signal into a digital signal, a digital form. Digital instruments are composed of the logic circuits that carry out measurement of the quantities. Due to number of advantages of digital instruments such as high speed, errorless results, better resolution, and greater accuracy over analog instruments. The popularity of digital instruments are increasing rapidly. Also, the digital instruments display the measured quantity in discrete numerals, thereby eliminating the parallax error and reducing the human errors associated with analog pointer instruments. In general, digital instruments have superior accuracy over analog pointer instruments, and many incorporate automatic polarity and range indication, which reduces operator training, the measurement error, and the possible instrument damage through overload. In addition to these features, many digital instruments have an output facility enabling permanent records of measurements to be made automatically. As we have already seen, a digital instrument is nothing but it displays the output form of numerals. So the advantages of the digital instruments over analog instruments are already we have seen this. It reduces the human reading and interpolation errors. It eliminates parallax error. It increases the reading speed. It gives high accuracy up to 0.003%. It possesses good reliability and repeatability. The output is available in digital form for further processing and recording and remote transmission. It has high input range from 1 volt to 1000 volts, very low power consumption, the wide range of frequency response and measurement, no loading effect due to high input impedance. It has got high sensitivity. It is small in size. The detection of low level signals is easy. Good visual readout and good quality. No human reading errors and no parallax errors. They have high input range with automatic range selection and overload indication. The input impedance is high. The resolution is better. The output in digital form can be directly recorded and is suitable for further processing. Also, with the development of the IC chips, the cost, size, and power requirement of digital instruments are drastically reduced. When you come to the basic building block of a digital instrument, it has the input analog section, the analog to digital converter block, the signal processing unit, and the display unit. The A to D converter. So almost all the instruments of digital have this A to D converter. So digital instruments, particularly digital voltmeters or multimeters, are used to measure the analog quantities. It is necessary to convert analog signal to an equivalent digital signal. So they are used as main elements of digital instruments. The signal processing unit uses a microprocessor for processing the digital signals. The digital decoders and the drivers are used to interface the digital output from A to D converters to the display unit. The basic building blocks of digital instruments are the display unit. It uses the numeric LED display or LCD for showing the reading of the measured quantity. Both LED and LCD displays are in a 7-segment format. So the basic building blocks of the digital instruments, the display unit consists of a 7-segment display. As you have seen here, these are the 7-segment display blocks. The first one is the 7-segment display. We're using that. They have shown how the numbers are displayed. The basic building blocks of digital instruments are each digit in the display has 7 separate segments. The numbers are formed by activating the appropriate segments that highlights the numbers. So I have seen what digital instruments are and the advantages of the digital instruments over the analog instruments. What are the basic building blocks of the digital instruments? So next is we will be going through the digital voltmeters. Digital voltmeters are essentially analog to digital converters with digital displays to indicate the measured voltage. Digital multimeters are electronic voltmeters with digital displays. So digital voltmeters are measuring instruments that convert analog voltage signals into a digital or numeric readout. This digital readout can be displayed on the front panel and also used as an electrical digital output display signal. So any digital voltmeter is capable of measuring analog DC voltages. However, with appropriate signal conditions preceding the input of the DVM, quantities such as AC voltages, current, resistance, DC and AC current, temperature, and pressure can be measured. The common element in all these signal conditioners is the DC voltage, which is proportional to the level of the unknown quantity being measured. This DC output is then measured by the digital voltmeter. So digital voltmeters have various features such as speed, the automation operation, and the programmability. The digital voltmeter displays AC and DC voltages as discrete numbers rather than as a pointer on a continuous scale as in an analog voltmeter. A numerical readout is advantageous because it reduces human error, eliminates parallax error, increases the reading speed, and often provides output in digital form suitable for further processing and recording. With the development of IC modules, the size, the power requirements, and the cost of digital voltmeters have been reduced so that DVMs compete with analog voltmeters in portability and size. The digital voltmeters are classified mainly as the ramp type digital voltmeter, the dual slope integrating type digital voltmeter, the integrating type digital voltmeter, the staircase ramp type digital voltmeter, the successive approximation digital voltmeter, the continuous balance type digital voltmeter. So these are the different types of voltmeters of the digital type. So in which we will be going through the each type of voltmeter separately. Now to summarize, we have already seen what a digital instrument is. As I have already told you, the instrument which represents the measured value in the form of the digital number is known as the digital instrument. It works on the principle of quantization. The quantization is the process of converting the continuous input signal into a countable output signal. So, the instruments that are used to express the measuring quantity in numeric format is known as digital instruments. Quantization is the basis of working of a digital instrument. It is an act of transforming an analog signal into the digital form. Digital instruments are composed of the logic circuits that carry out measurement of the quantities. Due to several advantages of digital instruments such as high speed, errorless results, better resolution, and greater accuracy over analog instruments, the popularity of digital instruments are increasing rapidly. Also, the digital instruments display the measured quantity in discrete numerals, thereby eliminating the parallax error and reducing the human errors associated with analog pointer instruments. In general, the digital instruments have the superior accuracy to analog pointer instruments, and many incorporate automatic polarity and range indication, which reduces operator training, measurement error, and possible instrument damage through overload. In addition to these features, many digital instruments have an output facility enabling permanent records of measurements to be made automatically. So the main advantages of digital instruments over analog instruments are they are superior to analog instruments. They have high accuracy They are small in size, low power consumption, high frequency range, the detection of low level signals, high durability, good visual readout, good quality, no human reading errors, no parallax errors. They have high input range with the automatic range selection and the overload indication. The input impedance is high, the resolution is better, the output in digital form can be directly recorded, and it is suitable for further processing also with the development of IC chips. The cost, the size, and the power requirement of digital instruments are drastically reduced. So we have different types of digital instruments like digital voltmeters. We have the digital frequency meters. We have voltmeters of different type like a ramp type voltmeter, the successive approximation type voltmeter, the dual slope integrating type of voltmeter, each one having its own advantages and few limitations. Along with these, we'll be studying there are digital frequency meters, there are digital LCR meters, and how the different factors affect the accuracy and resolution of the frequency meter. So here we are seeing that the basic circuit of the digital instrument is nothing but we have seen it has analog to digital converter, the signal processing unit, and the display unit. So whatever instrument we are using, whether it may be a voltmeter, whether it may be a frequency meter, whether it may be LCR meter, so whichever signal, the type of signal, we want to measure the voltage, whether we want to measure the frequency, whether we want to measure the L, C or R, whatever it is, the signal is first converted from analog to digital. We have studied, we know different types of analog to digital converters, which is given to the signal processing unit and then finally to the display unit. Here, excuse me, the display, in digital instruments, they display the output in the numerical form, that is in digital form. Digital instruments are used to measure the voltage, the current, the power, the frequency, etc. To enable these digital instruments to recognize information inputs which are analog in nature must be converted to digital form. Hence, any digital instrument consists of an analog to digital converter at its input stages. The basic building blocks of digital instrument we have already seen. So any digital instrument may consist of the resistors, the capacitors, the transistors, the linear ICs, the digital ICs, the display devices, analog to digital converters, digital to analog converters. So the display block may be analog or digital in nature. So if analog readout is required, a stage involving digital to analog converter can be included before the display. So here, as I told you, we'll be going through the different types of voltmeters like ramp type digital voltmeter, the successive approximation type digital voltmeter, the dual slope type integrating type of digital voltmeters. So they have got their own advantages, they have got their own limitations. So the problems which encountered in one type of circuit were tried to be overcome in the next circuit. Again, the problems which were faced in the next circuit were improved in another circuit developed. So in this way, the voltmeters from basic RAM type digital voltmeter to successive approximation type digital voltmeter and dual slope integrating type digital voltmeters were designed. So as in our analog meters, in digital voltmeters we have the automatic the range automatically the range can be selected, the polarity can be selected. So we may have the different ranges also which can be selected so that it can be used conveniently and comfortably. Also, already we have seen a voltmeter always should be connected in parallel across the component or across the circuit where voltage has to be measured. Next, the polarity has to be observed. Next thing is the range selection also is better. We connect this voltmeter in the circuit with a higher range and then select the required range depending upon the way the reading is observed. Supposing it is showing 0.005. If you want to read it comfortably, reduce the range so that it will show you the correct voltage reading. So in this way, we can use the digital instrument. So these are the basics of the digital instruments, what a digital instrument is, what are the basic building blocks of a digital instrument. Next is what are the advantages of the digital instrument over the analog instrument, and finally what are the different types of instruments that we can build up in digital version. So this is all about the digital instruments and the advantages and the different types of classification of the voltmeters. Thank you.